Hey guys, coming at you with another enthralling video about math. And we're continuing our series on geometric proofs. This time we're talking about segments and angle bisectors. Respect a couple of things here. This is not an all-encompassing video. This video is just talking about how to use segments and angle bisectors in a geometric proof. It's an introductory video at best. The goal of this series is to go through the number of properties in geometric proofs, do them separately, then hopefully, as you guys need to, you can apply them all together. Respect, again, that geometric proofs are very difficult. They take a long time to get right, but it's a worthwhile skill to get right. We're talking about making logical arguments, backing up arguments or statements with facts. Something, if you ask me, is a sorely needed skill in this world. Okay, so here's the agenda for this video. First, we're going to talk about what congruency is. Then we're going to go through the 5 congruency postulates. Then I'm going to define bisector for you. Then we'll do a proof that involves both segment and angle bisectors. Okay, let's take a look. Okay, first, congruency. All congruency means is that it's a physical concept where everything between two things is exactly the same. So these two triangle monsters here are exactly the same in every way, so they are congruent. That's the idea behind that. It's different than equivalence. Equivalence is a numerical concept. 5 equals 5. Where congruency is a more of a physical kind of thing. We're talking about how things are exactly the same. Next, the 5 congruency postulates. Okay, and I put that one upside down, so let's flip that over. There we go. Okay, I have the 5 different methods of proving triangles are congruent or stating that two triangles are the same. One requires 3 pairs of sides. If I have 3 pairs of sides in side, then I can state these triangles are the same. 2 pairs of sides, and then an angle in between them, pair of angles in between them, can state that these triangles are the same using side, angle, side. Angle, side, angle uses 2 pairs of angles, and then a included side, pair of sides, states that these triangles are the same. A pair of angles with a side that's not included, the side is on the outside, can claim that these 2 triangles are the same, and that's angle, angle, side. And then if you have a right triangle, we could use hypotenuse leg. Okay, the hypotenuse is the longest side of the right triangle, then the other 2 sides of the legs, and you could prove the 2 triangles are congruent there. I went through that really fast, but I have a specific video on the 5 congruency postulates. Next, let's talk about what bisector is. Bisector, or to bisect something, is just to divide something into 2 equal parts. Okay? If I bisect a sandwich, that sandwich is into 2 equal parts. That's it. Okay, so now let's take a look at a proof. Okay, so here's a kind of a viable proof I wrote out to use both bisectors of a segment and bisectors of an angle. Here is the segment. So this is the segment bisector here. And this is the angle bisector. Okay, so let's take a look at what that does. So it says here, I'm going to actually start the black one. It says here that the DC bisects AB. DC, that's this line, is going to bisect this line. So let's go back to the sandwich metaphor that I was using, or analogy. DC is the knife, AB is the sandwich. So this knife is cutting that sandwich in half. The knife itself does not get cut in half. DC bisects angle ACB. That's happening here. And this angle is being cut in half by this line. Okay? So all that stuff, and then they told me that the angle A is congruent to angle B. So all that stuff is given. So you write the given down word for word. And the reason for knowing that is because it's given. So given, given, and given. Okay, now let's take a look at how to use this stuff. So first I'm going to address the segment bisector. So the segment bisector, DC bisects segment AB. That means this line is cutting this line in half. So if that's the case, right, that's going to make this side and this side congruent because this is cutting in half. Now, if you're wondering, wait a minute, that does the same thing as a midpoint, you are totally correct. In this case, and in most cases, midpoint of a segment and midpoint of a segment and a segment bisector do the same thing. It's slightly different language. One is saying it's the middle, the other one's saying it's cut in half, but the results are the same. So I'm going to say that AD is congruent to BD, and that's because DC bisects AB. So I'm actually going to write that here. DC bisects AB. There's a couple of ways I can use this language, but that's the most direct way to say it, and I'm sticking with that. So next, I have DC bisects angle ACB. So this line is cutting this angle in half. So as a result of that, I have now two angles here that I could use. Okay? So that is a result of that being cut in half. So I could say angle ACD is congruent to angle BCD. And that's happening because of that. Now, I have to state, a couple things I just want to mention. I have to state that these things are happening before I could use them. So that's kind of why it's being written here and then being used as a reason. It's being used as a statement, then a reason here. That's me kind of laying out my evidence and then using it. And let's try angle ACB. Okay? And there's my trials and tribulations of being left-handed. Now, it also says here that those angles are congruent, so I'm going to mark those off. There's those. Okay? Just a little notation here I want to point out. So, notice those have two arches, and this has only one. These angles are congruent, and those angles are congruent. The number of arches just indicates that these angles are different from that. If I wanted to, I could have put 30 arches there and 15 here. It wouldn't have mattered. That's just not the most efficient way to do it. Now, from there, I'm going to state, let's take a look. This here is angle side. Let me double check on this side. Angle, side. So that's the postulate that's going to fit here. Angle, side. Okay, guys. That's bisectors, both segments and angles. I hope you guys found this video helpful.